today we are taking the conversation into manufacturing sector, where one of the biggest barriers to scaling AI isn't technology, but rather it is data. Manufacturers generate enormous volumes of data across both operational technology and information technology. These remain initiatives often struggle to move beyond isolated pilots. Well, that is exactly what we are discussing in today's session. We'll explore why unifying OT and IT data has become the foundation of successful AI transformation, and how manufacturers can build trusted data architecture and what it takes to enable enterprise AI or industrial AI, digital twins, predictive operations, and autonomous manufacturing at scale. I'm delighted to introduce our speakers for today. We have Narayan Gokhale, Vice President and Principal Advisor. Along with him, we have Devendra Pajanis, Associate Vice President and Principal Advisor for AI Transformation. Well, together they will share practical insights from enterprise tech advisory, engagement, and real-world manufacturing transformation initiatives to help organizations accelerate their AI journey with confidence. We encourage all of you to share any question that you may have in the comment. With that, started and Narayan.
Thanks, Anish, for that introduction. And welcome everyone to this particular webinar on unifying OT and IT data, the foundation for AI transformation in manufacturing. And the most important topic that we are going to dwell on, as you can see, is why a particular AI initiative succeeds or fails based on data foundation. So I'll take a couple of minutes in terms of the introduction and setting the stage. My name is Narayan Gokhale. As Anish had said, I am the Vice President and Principal Analyst. I have 3.5 decades of experience, mainly addressing the verticals of industrial or manufacturing, energy and utilities, smart buildings and infrastructure. And I've been associated with the hardware, software, and services business. And actually, I'm very pleased that my co-host today is Devendra. And the way in which we'll run this particular webinar is I'll talk mainly related to manufacturing, OT, IT, ET, and Devendra, who comes from our AI transformation team, he'll talk mainly about the AI and its implications. So that's how we'll kind of run you through this webinar. So before I move forward, maybe Devendra, a quick introduction from your side.
Yeah, thank you, Narayan. Anish, thank you for hosting this webinar. And Narayan, it's an honor and privilege for me to be on a part of this stage along with you. A very quick introduction about myself. I come with about 3 decades of experience in manufacturing, retail, CPG. And more recently, as a part of the QKS Group, I have been responsible for AI transformation initiatives, mainly working with leadership teams across large manufacturing enterprises, helping them design their AI business strategy, defining the right high-impact business opportunities, and then translating them into sustainable roadmaps. So looking forward, Narayan, to a great webinar. Back to you.
Thanks, Devendra. So let's get started. And as I said, I'll just quickly set the stage before I kind of run through the agenda. So, today, AI has become dominant topic in almost all conversations, needless to say that. And when I and our team, we kind of interact with manufacturing executives, be it CIOs, CIOs, CDOs, operations leaders, or the industrial software, people, as my role as a principal advisor, it gives me a unique opportunity to kind of interact with hundreds of such stakeholders through industry briefings, customer discussions, major global events, strategy sessions. So all these discussions, and as you can guess, these are diverse discussions. One consistent observation is continuously emerging. And that is that every organization is now investing in AI. They have successfully built AI pilots. They're doing POCs. But surprisingly, and as we see consistently, not all of them or only a few of them have been able to scale, AI across multiple plants, multiple business units, and enterprise as a whole. So initially, many organizations thought that choosing the right AI model was a challenge. But today, the conversation has shifted. Executives are asking a different question altogether. How do we operationalize AI across enterprise, and that too consistently and generating measurable business outcomes? That's the shift in conversation that we are noticing. And so our research shows that, the answers lies deeper than AI algorithms. And the impact that is created is not because of AI models, but because of trusted industrial data, modern data architectures, governance, and cross-functional execution. So reason I'm kind of saying is this is what you will hear from both of us in much details. So that's the reason I'm kind of laying this stage. So AI success has fundamentally become a data and transformation challenge rather than just a technology challenge. So today we will explore why unifying the OT, which is the operations technology, the IT, which is the information technology, and increasingly more often now, even the ET, which is the engineering technology, they all are becoming an essential foundation from an enterprise level AI in manufacturing organizations. So rather than just focusing on individual technologies, we are observing a broader trend in manufacturing industries as to what they're doing differently, where some continue to struggle, and what are the practical lessons that every manufacturer can draw from this. So with this, setting the stage, the webinar agenda is right in front of you. So we'll kind of start with what we are observing globally and how manufacturing is entering a new era. Then Devendra will most importantly discuss as to why the AI initiatives tend to stall. What is the biggest manufacturing AI problem? The IT, OT, ET convergence we talked about. Then about the industrial data readiness foundation. How is the new industrial data stack or architecture emerging? New concepts like UNS, data platforms. Then which are the most important outcomes that we are seeing today? The industrial AI maturity model, and the recommendations for the manufacturing CXOs, and to conclude how QKS can help manufacturing executives go through this particular transformation. So that's the kind of agenda that we are into. So let's kind of deep dive and move into the next slide. Okay, so what we are observing globally, and you will see me talking about this more often. So in this year 2026, I had the opportunity to visit Hannover Messe in April 2026, and of course interactions with a lot of IT vendors, OT vendors, automation vendors, global system integrators, and most importantly, end users. Plus, I have had opportunities to attend several analyst day events of ABB, of LTTS, e-infochips, and across those conversations, one could see, the discussions converging from automation towards autonomous operations, leading to, connected operations or data-driven operations to AI-assisted operations and autonomous operations. So the takeaway of most of these discussions is we definitely see the competitive advantage now moving from automation to intelligence. So everyone agrees on the destination, but very few are ready. Now let's understand what this really means, getting into some deeper perspective. So as you know that for decades, just stay on that slide, Anish. Yeah, so you see, like when you talk about automation, we have traditionally seen, PLCs, DCS, SCADA, MES, all talking about industrial connectivity and productivity, operational efficiency. But today, the conversation is repeatedly kind of converging around themes such as industrial AI, digital twins, unified industrial data, agentic AI, and now more and more into physical AI as well. So the conversation is no longer about can we automate this process? The conversation is now shifting to can our systems continuously understand what is happening, predict what will happen, recommend the best course of action, and eventually optimize operations with minimal human intervention. Now, that's a profound shift, and that's where the connected and contextualized trusted data will come into picture. So now executives asking questions, as I just mentioned, how can you help us move from isolated pilots to repeatable business outcomes? So what I often tell manufacturing leaders is, that you may have data, you may have excellent dashboards, you may have some pilots, but the data foundation is required in order to scale data across multiple plants and business unit. So that is the biggest challenge. And that actually then leads us to think is like how manufacturing is now entering a new era. And if you could move on to the next slide. Actually, there are two slides about manufacturing entering the new era. And I'll kind of walk you through both of these particular slides. So one thing about a manufacturing entering new era is about some mega trends that are reshaping manufacturing. And those 6 mega trends are right in front of you. And I'll get a deep dive in a minute. So the manufacturing, which is entering a new era, is not Industry 4.0. It's not just digital transformation. It's not just only AI. It is people, machine, assets, engineering, operations, AI agent who are continuously collaborating. So the takeaway, the next competitive advantage will not come from just deploying more AI. It will come from connecting enterprise knowledge. And most importantly, the manufacturers have now realized that we have solved the problem of automation. The next challenge is, addressing the enterprise intelligence. So let me just deep dive into some of the mega trends that have been listed here and why it is very important for manufacturing sector as a whole. First and foremost is the workforce challenge. You have senior people retiring, some of them leaving, maintenance specialists, plant operators, and difficult to replace. So it is not just a loss of headcount, but a loss of decades of operational knowledge. At one point of time, it seemed that it was a difficult problem to solve, but now with AI, there is a way to capture, augment, and preserve that expertise. The second challenge is supply chain volatility. We have seen ever since COVID and now into a lot of geopolitical tensions that supply chain volatility is for real. It's not just a transient phase. So therefore, organizations will need greater visibility, better predictive capabilities, and agility across the enterprise and global supply chains. Third, very important, is about sustainability. We're talking about carbon footprint, we're talking about energy transition, we're talking about ESG, and now AI provides intelligence to balance, often which are these particular competing needs or competing objective. So that is another good thing that is happening. The fourth area is around cyber resilience. Again, we've seen plants like, Jaguar getting closed for weeks, Jaguar Land Rover, due to ransomware attack. And so now boards are asking, how AI can, help secure the plants as well. And finally, software-defined manufacturing is coming into reality. So therefore, you will have software which is increasingly connecting services, industrial data, and products. So this is really reshaping the manufacturing. And then, what are another implications, as some people call is move away from Industry 4.2 into the industrial AI era. So let's move to the next slide where we'll talk more about how this transition is happening. Next slide, please. Okay. So what has fundamentally changed? Like what people are saying, manufacturing industry or observers are saying, moving from Industry 4.0 to the era of industrial AI. So the manufacturing leaders, executive, and the market as such is no longer asking the questions which used to get asked yesterday. You'll see in front of you on the slide and how those questions are pivoted, much more AI specific. So the takeaway that we are seeing is, manufacturing is entering an era where intelligence become embedded into every engineering, operational, and business decision. So as an analyst firm, as an advisory firm, what are the discussions, what are the questions that we are hearing? So manufacturing has evolved through distinct, innovation phases. The latest one of Industry 4.0 connected machines, assets, and people through digital technologies. Today, we are entering the next stage of that evolution. So it is not just connectivity, it is intelligence. 5 years ago, every conversation talked about digital transformation and connectivity. Now that has fundamentally shifted. It's no longer how do we connect machines. It is how do we enable those connected systems. I mentioned earlier, to reason, to learn, to predict. So while Digital 4.0 focused on digital visibility, today industrial AI is focusing on creating intelligent decision making. Earlier it was as to know earlier it was just generating data, now data that transforms into recommendation, autonomous actions. So if there is one insight, it is that the manufacturing's next advantage will not come from employing more AI models. It will come from bringing unified and trust data that enables intelligence. Okay, but having said that, still, why are so many AI initiatives struggling and not able to move beyond successful pilot projects? To throw more light on this, who else can do better than my colleague Devendra, who will kind of walk you through why AI initiatives are stalling, specifically to industrial AI. So, Devendra, keen to learn your perspectives on this particular subject.
And Narayan, thank you very much. And actually, you made my job a little easier because you have set the context in such a nice way. I'm going to be able to throw a little bit more lighter here. So you're right. One question I frequently get asked by a lot of manufacturing leaders and executives, Narayan, and the question is like this: if AI has so much potential, then why are so many initiatives struggling to scale, right? The interesting part here is that most manufacturing organizations have already started some amount of AI journey. Some are implementing AI in predictive maintenance, others are using computer vision for quality inspection, some are deploying engineering co-pilots to improve product development. You name a use case and it's available. Others are applying AI for production planning, forecasting, even energy optimization or supply chain visibility. So the issue, Narayan, is no longer whether manufacturers are investing in AI. They are investing heavily. The issue is whether they can scale beyond those isolated, successful pilot use cases that we talked about. And that is where consistently we observe a disconnect. One plant successfully deploys a predictive maintenance solution. The same plant within the organization selects a completely different platform. The engineering teams on their own build AI applications using some PLM data. Operations team parallelly rely on MES and SCADA systems. So business functions, procurement, they work within their ERPs and supply chain applications. So as you can see, every initiative does deliver a great local value. However, they often operate very independently, one ear not knowing what's happening on the other side, operating with different data models, different architectures, and obviously different governance practices that suit their own function. As a result, what happens is organizations accumulate a lot of successful pilots and they're very proud about it, without building a very successful enterprise AI capability. So one observation that has become very clear, Narayan, through our market research is that organizations rarely fail because the AI algorithms don't perform well. Actually, the AI models in today's world are becoming very powerful and very accessible. So the real challenge, in my opinion, lies somewhere else. It lies in the absence of a common data foundation, a consistent business context, and an enterprise-wide business model that allows AI to scale. That's why many organizations that we talk to and in our research find themselves managing dozens of successful pilots that they are very proud of, but very few, about 10 to 15% is where we see enterprise-wide AI programs. The industry challenge, hence, today is no longer AI adoption, it is AI operationalization, which naturally raises, another question from a manufacturing perspective. If organizations already possess enormous amount of industrial data, why does the scaling of AI remains so difficult? And Anish, if you can move to the next slide, the real answer lies in the context, all right? The word context. Uh, and let me explain that a little bit. Technology is rarely the primary obstacle here. The real obstacle is the lack of enterprise transformation. Again, based on our research and interactions with a lot of manufacturing organizations, and Naren, you experienced that at Hannover Messe as well. There are typically 7 barriers that we can call out that appear repeatedly across industries, regardless of geographies or markets, or even manufacturing segments. The first no-brainer, it's data silos. Critical operational data exists, but it is distributed across hundreds of systems that were never designed to work together. Second, while the data is there is lack of qualitative data. Industrial environments generate enormous amount of data, but much is complete, it is inconsistent, at times it is duplicated, or even lacks the contextual information that is required for AI. The third one is the persistent disconnect between operational technology and informational technology. Plant force systems, enterprise systems often continue to operate as separate worlds. They never integrate together, making enterprise-wide intelligence extremely difficult. The fourth challenge, often overlooked, is the legacy interface and the infrastructure that's existing. Many manufacturing facilities that we have researched continue to operate assets that are 20 or even 30 years old, because it's always difficult to suddenly bring in new capital expenditure. These systems remain highly reliable from an operational perspective, but were never designed for today's AI infrastructure. The fifth one, something that's hated by everybody, governance. Organizations frequently underestimate the importance of common business semantics, ownership, data stewardship, security policies, and lifecycle management. This is always considered a barrier towards speed and accuracy. The sixth challenge is the skills gap, the people aspect. Successful industrial AI requires deep expertise across manufacturing operations, engineering, data science, and enterprise architecture. These capabilities very rarely reside within one team. And finally, the most important one, many AI initiatives lack a clear business ownership. One insight we increasingly share with our clients is most manufacturers do not have an AI problem. They have an enterprise integration and a data context problem. That distinction fundamentally changes how organizations should approach AI transformation. With that, let me move on to something what we just talked about is contextualized industrial data. And Anish, if you can move on to the next slide, I really want to bring across the question in terms of why does AI fail to make the same decision that an experienced plant engineer of maybe even a couple of years experience can make in a few seconds, right? So AI does not fail because it lacks intelligence. AI is intelligence, right? It fails because it lacks the industrial context behind that intelligence. And let me take a practical example that many of you would probably immediately recognize with. Imagine in a factory, a critical compressor on a production line suddenly starts exhibiting some abnormal vibration, a very common problem, right? So what a modern AI model will do is it will easily detect the vibration exceeding the normal operation threshold. So if the threshold is 100, if the vibrations are beyond 100, AI is immediately going to detect and raise a signal. In fact, the anomaly detection has become relatively straightforward today with the technology that's available. But now comes the most important question. What should the organization actually do when the compressor is throwing vibrations beyond the threshold? Should the equipment continue operating? Should maintenance be scheduling during the next plant shutdown, or should we plan a shutdown right now? Should production be rerouted to another production line? Is there a spare unit available that we can do an immediate changeover? Or will replacing this component impact customer deliveries that are scheduled during this production run? This is where AI requires context. The vibration reading stored in some historical data. Maintenance records are typically maintained in some asset management systems. The engineering specifications for these compressors and equipment configuration reside within your PLM or your engineering systems. Makes sense, right? And production schedules and operational constraints that we require to do a changeover of line typically come from your ERP systems. Now, each of the systems that I talked about contain very specific information, yet none of them individually tell the complete story behind this vibration of this compressor. An experienced, reliable engineer finds all of these information together before making a decision. AI must be the same. Without connecting all this information together, the AI model may not be able to take an action on the anomaly, but it can confidently recommend the best operational action based on the past data. This distinction is extremely important in my opinion. Detection is not intelligence. The action that follows the detection is important. And that's why we are precisely still seeing a lot of growing interest in technologies such as industrial data platform, digital threads. Narayan talked about UNS, semantic data models, knowledge graphs, as well as industrial data fabrics. All the systems share an operational context so that engineers, operators, and business applications all interpret the same data in the same way. Organizations that invest in contextualizing this industrial data are able to deploy AI in a much faster and in a much better way in our experience and in our research. So industrial AI is not fundamentally a system or a machine learning problem. It's an industrial knowledge problem in our opinion. And as I said, organizations that succeed will be those that make this operational knowledge available at one go rather than in isolated pieces. So the question is no longer whether AI works. And Anish, if you can move on to the next slide, the question is whether organizations are ready to operationalize AI at enterprise scale. So if you look at it from a differently complete challenge, as analysts, one of the biggest shifts we have observed over the last year is the evolution of executive conversations. 18 months ago, I remember many discussions centered around AI experimentations. Today, executive teams are asking more strategic questions. How do we scale AI? How do we govern AI? How do we reuse AI across multiple sites? How do we measure enterprise value rather than isolated success? These are fundamental transformation questions, not technology questions. I recently had a conversation with the CIO of a large manufacturer, and Narayan, you remember I spoke to you about it last week. They shared that the organization had launched 70 AI initiatives. Let me repeat, 70 AI initiatives across different functions. Naturally, my next question was how many of them had evolved into a standardized enterprise-wide capability? And the answer was, out of the 70, we could only standardize and scale less than 10, single-digit number. That conversation, I feel, is not unique. It's a very common discussion. And we hear similar stories across many manufacturing organizations. The lesson here is straightforward. AI pilots are relatively easy, but building an enterprise AI capability from a manufacturing segment is significantly more difficult. The organizations that recognize this distinction early are the ones most likely to achieve long-term success. Because every successful industrial AI journey begins with one essential trusted capability, that's connection and contextualized industrial data. And with that, Narayan, I invite you to talk about how OT, ET, and IT conversions really matter when it comes to an AI perspective.
Thanks, Devendra. Thanks for that very unique perspective about why industrial AI initiatives stall. Then unique, manufacturing AI challenge in terms of contextualization, and most importantly, the unique problem that you mentioned about from pilots to actually scaling. So thank you very much for getting that unique perspective, especially for manufacturing industry. So moving on, let me kind of bring in a very important aspect about OT, ET, and IT. So Devendra did touch upon some of it. So I'll be quick since we are already kind of half an hour into the conversation. So basically, OT is talking about sensors, machines, PLCs, SCADA, historians. IT is all about business systems, and ET is about engineering systems. So essentially, three worlds, three languages. So, and manufacturing organizations are trying to build enterprise AI on all these three disconnected worlds. Each world has its own vocabulary, own identifiers, own processes, and own governance. So, AI requires all three in order to have the enterprise intelligence and one unique intelligence layer. So just if you take one use case, for example, like predictive quality, you are trying to predict the quality of your product, so it has to have strong connections with OT, ET, and IT in order to get the right outcomes that the industry really requires. For example, reduce scrap, lower rework, faster root cause analysis, and improved first pass yield. So diving a little bit, as to how this actually happens or can happen, is basically these three worlds we just talked about, IT, ET, OT. So engineering defines what should be built, operation determines how it is built, and enterprise systems determines how the business manages it. Imagine three environments which have been managed independently. They have their own terminology. So, but AI has to change that equation. It is expected to optimize the entire value chain than just individual processes. So Devendra did talk about the example about the vibration on the compressor, and it gave the idea as to how the context and the convergence of IT and OT data is really, really important. So I really won't be talking about more use cases like that. But to kind of highlight, it's always OT and IT data that is highlighted, but engineering data is becoming equally important because ET is becoming the bridge between product innovation and operational execution. So just to add another real world example, questions that often get asked, and we are part of many of those discussions, is which engineering change introduced last month is responsible for today's increase in production defects, for example. So AI must understand, right, going to the ET systems, product design, engineering changes, data from MES, data from quality systems, from maintenance systems, supplier systems, and ERP. So these organizations, if these particular silos are connected, the promise of enterprise AI still remains a promise. So AI does not operate within or cannot operate just within those silos. It has to learn from connected business context. So that is where the convergence of IT, ET, and OT matters. That leads us to the next slide, and where we'll talk like where does this particular convergence lead us to? It leads us to the data foundation, the industrial data foundation. So what does industrial data really actually mean? It actually means that the data has to be connected, contextualized, trusted, accessible, and governed. Without these, industrial AI just cannot scale. We touched upon in our earlier discussions, and at the cost of repetition, at to some extent, in order to drive the point about this particular foundational aspect of industrial data readiness. So industrial AI is not a data problem. It is a data problem and not a AI problem, as we have been kind of saying all along. Let me just give you one example again, where we are a part of discussions. Suppose I ask AI assistant why production line 3 lost 12% throughput yesterday. Can it answer with confidence? Oh, manufacturing executives will say somewhat. It's not because AI is incapable. It's because it is collecting information from isolated places. It may know temperature, it may know vibration, it may know maintenance work order, but without the coherent operational narrative, you'll still have those not yet or not yet ready kind of answers that is kind of coming through. So another example is a pharmaceutical manufacturer. More than 150 production assets were connected. As Devendra mentioned, anomaly detection was easier, but recommendation lacked business relevance because it did not understand the production genealogy, very important in pharmaceutical operations, regulated batch history, quality release history, and engineering change records. So the main takeaway as an analyst firm for manufacturing executives is organizations that invest early into data governance, semantic models, unified data, and contextualizations will move faster from pilots to enterprise scale AI. Okay, so having talked about industrial data as a key foundation, how does the modern stack or modern architecture look like? Let us go to the next slide. So before we kind of get into the stack, there is one important thing that I want to highlight is like now not everything is visible to the plain eye when it comes to AI projects. As you see in this particular slide, the AI projects are just the tip of the iceberg. But what is beneath it is actually making it successful or not so successful, and the business impacts that it particularly creates. So basically, organizations pay what I call it as hidden tax of poor industrial data if the data foundation, data readiness is not really up to the mark. Okay, so one particular example I would like to cite here is for an computer vision application in automated inspection that was implemented across several plants. The pilot, of course, delivered results, but the inspection standards were different. The quality taxonomies, which is very important, were again different. And the local level of intelligence that Devendra mentioned, they were able to get it to a certain, but not on an enterprise level. So the business impact, as you would see on the right-hand side of this particular slide, what does all this relate to? Longer AI deployment cycles, higher implementation cost, increasing engineering efforts, duplication of initiatives, inconsistent operational decisions. Most importantly, it tends to lower employees' trust in AI and its recommendations, which is harmful in the long run. The executive's confidence also tends to get reduced, and therefore all these leading to slower realization of business value. So moving on to the next slide, as I just mentioned about the modern industrial data architecture or the data stack. This is how a typical modern data architecture stacks are looking, right from sensors to edge level to more of connect data platforms, context layers, UNS, enterprise data platforms, AI, and business applications sitting on top of it. So what industry directions are we seeing? That the architecture that I just talked to you is increasingly consistent across software providers. Implementation tends to differ, but the principles do not differ largely. So that is basically the stack or the modern architecture we are seeing, where newer concepts such as UNS, industrial data fabrics, knowledge graphs, semantic data models, event-driven architectures and data threats are rapidly emerging. I will not give many examples because we already discussed quite a few examples. Let me move on to the next slide, which talks about the concept which is called as UNS, a unified namespace. Now, this is just one particular aspect, UNS, which we are kind of covering it here, but that's the only one. It's just for sake of representation. You have organizations like OPC UA coming up with, FieldX or Field Connect or to Cloud Connect initiatives. You have I3X coming out with a lot of initiatives which are similar to UNS, which is creating one common language for manufacturing. Because intelligent systems store data in its own systems, but now with unified namespace, everyone publishes, everyone subscribes, and so there is the same optional context that is there for all the users in a manufacturing organization. So UNS is kind of becoming an operating layer for industrial AI. I just told you it's a concept, it's not a software product. It's a kind of an architecture philosophy. And in order to move from data silos to a connected industrial intelligence, concept like these are becoming an integral part of industrial data platforms, which are rapidly emerging nowadays. So let's move on to industrial data platforms and why they are becoming very strategic. Next slide, please. Okay, so I just touched upon the earlier traditional role of platforms was just to collect the data, store the data, and visualize the data. But now with AI, you will need to contextualize it, you will govern, you will need to orchestrate it, make it AI ready, support digital twins in order to have more predictive outcomes, enable agentic AI. So industrial data platforms are becoming very, very strategic for all the AI initiatives that are taking place currently. I would kind of relate it to things that were happening maybe 2 decades or a little more than that. For example, industrial data platforms are becoming what ERP systems became during enterprise transformation 2 or 3 decades ago, I just mentioned. ERP, unified business processes. Industrial data platforms are beginning to unify operational intelligence. And in the coming years, based on our interactions and our research, manufacturers are unlikely to compete solely on who has the best AI models, but the competition or the advantage comes from who has the best industrial knowledge available for those AI models to learn from. So that is the really importance for industrial data platform strategic place in today's manufacturing organization. Moving on. Now, what is this really enabling for manufacturers in terms of business outcome? I would kind of categorize them into 6 major outcomes: predictive maintenance, predictive quality, production optimization, energy, digital twins, and autonomous operations. So all of them are self-explanatory. I would not really go into too many details of each of them because all of these deliver, or we are seeing deliver business outcome. Let me just summarize them for lack of time. For example, in predictive maintenance, you see downtime come down to with a range of 20 to 40%. That's huge. For maintenance, or rather maintenance cost, the reduction can be from 10 to 30%. The overall equipment effectiveness, OEE, again, common term used in manufacturing, operation excellence, 5 to 15% improvement. Energy consumption, very important input costs for manufacturing, again, 10 to 20% reductions. Then quality defects or reduction in scrap, 10, 15, and even 40% in some very, very good use cases. And then root cause analysis and operational decision making, again seeing a 20 to 40% improvement. So these business outcomes are quantified outcomes are really huge for the 6 outcomes which we have been able to shortlist based on the research and analysis. Now, let me just pause for a moment and bring Devendra in to talk about how is what we just discussed so far, how is it kind of evolving into an industrial AI, maturity model, and taking us from where we are today to how does the journey look ahead, the journey of autonomous operations or autonomous manufacturing that we have been kind of talking about. So, Devendra, your perspective?
Thank you, Narayan. And the short answer there is industrial AI is really becoming the operational intelligence layer. So, I'm going to share something which we have researched called as the industrial AI model. Organizations progress through successive stages of capability, with each stage building on the previous one, and you really can't skip one or the other. And that's coming through our research and talking through several conversations with manufacturers. So very quickly, each level builds upon the first one. So the stage one is disconnected, where it's pretty much self-explanatory. The data and the information is fragmented and reporting is largely manual. Then you move one step ahead, where your AI maturity stage moves to a more connected level, where connectivity improves significantly, data begins to flow across systems and is not isolated. And then it moves to stage 3, where it is more contextualized. We talked about getting the context behind the data. This is where OT, IT, and engineering data are all brought together to build a context behind the data. This is where raw information then converts into business intelligence. The stage 4 is where really it takes a quantum leap, because the data that's now unified and contextualized is now kind of used from a predictive perspective. So rather than asking what happened, you are now starting to ask, why did this happen, or what is it likely to happen the next time? You remember the compressor example I gave. It was not about the vibrations, but when is the next time this compressor is going to give a similar level of vibrations. The stage 5 is where you get into the next level, where it not only tells you in terms of what happened or when is the next time it's going to happen, what is the course of action that you are getting. So a prescription in terms of what is going to be the action required. And then the 6th stage is really where it becomes really autonomous. Now, when we talk about autonomous, doesn't mean it's a light out factory or removing people from operations. Instead, what we are saying is routine operational decisions become increasingly automated within the right guardrails and the governance operations, right? So it optimizes production, it coordinates assets, and then it brings in an overall efficiency from an end-to-end supply chain perspective. Very few manufacturers are here today. Most manufacturers, Narayan, in my analysis, fall between kind of the 3rd to the 5th range, and only 10% lie in the bottom 2 or in the top 1, right? Some digital leaders are beginning to implement productive AI implementations in many manufacturing zones. Fully automation or automated operations remain very limited to select use cases and controlled environments. So I think that's pretty much from an AI maturity perspective, Narayan. And I'm sure with your experience in Germany from the Hanover Messe perspective, you might want to share some perspective linking it to the AI model. Anish?
Correct. So thanks, Devendra. And why are we talking about Hanover Messe? First and foremost, it is one of the largest exhibitions or trade shows in the world catering to manufacturing or industrial segment. So as analysts, as advisors, it's always rewarding when we talk to the stakeholders there and kind of get our research validated. So Hanover Messe confirmed that industrial AI has moved beyond experimentation, and the industry is now focusing on operationalizing AI. You heard this term in this webinar quite often, and moving towards enterprise scale, and most importantly, building foundation autonomous operations. So I won't really take too time going into too many details, but one important lesson that now AI is becoming enterprise-wide strategy. Like not from conversations moving from how can we use AI to how can we redesign operations around AI. Second, data. We talked about data quite a lot in this webinar, and data readiness has become more important than AI models. So that's another thing, lesson that we kind of got it validated. Most important, edge AI is becoming a core enterprise architecture. Earlier, it was only about cloud AI. Now it's edge AI. Agentic AI is now fast emerging. Okay, that's signal. Those are the signal we got from Hanover. And then autonomous operations is becoming a shared destination, a strategic vision for manufacturing organizations. Next slide, Anish. So as we kind of move towards conclusion part of this particular webinar, there are some recommendations based on our research and advisory that we provide to various stakeholders. So my first recommendation to the manufacturing CXOs would be build your data foundation before expanding into AI. Second is scale governance before scaling AI. Focus on business outcomes, not technology. Think enterprise-wide, not in silos or department-wide, and build for continuous, transformation. So these are my recommendations for manufacturing CXOs, and we can deep dive into each of these at an appropriate time. So I guess this it's time to connect the dots. Having looked at where we came from, how manufacturing is moving, the new AI model. Now, how can QKS help? What is QKS doing in terms of enterprise transformation, or most importantly, AI transformation? I'd request Devendra to share his perspectives to kind of lead us to its logical conclusion. Devendra?
Yeah, thanks, Narayan. So, over the last decade, for our audience, QKS has built a lot of deep research and advisory capabilities across IT, OT, and engineering technology. So it gives us a very unique perspective in terms of how technology, business strategy, and industrial operations are converging together. So our role is intentionally different. We have differentiated ourselves from a software vendor or a system integrator. We are technology independent. We at QKS do not recommend one platform or another. We actually instead help organizations make better strategic decisions. And how we do that is what we have on screen here. We do help organizations do their current assessment AI priorities. Is the organization really ready for an enterprise AI? What are the AI gaps in terms of AI readiness assessment? We looked at some amount of industrial data assessment, and then we look at building a transformation roadmap or a blueprint for your organization, defining priority use cases, and defining a 30, 60, 90 roadmap so that we can identify those priority use cases. Finally, through our ongoing market research, through our Spark Matrix evaluations, advisory engagements, and industry benchmark, we provide a very independent perspective on technology providers, market trends, and best practices. So essentially, if Anish, if you can move on to the next slide, what we have here is something that over a period of time, QKS has built what we call as our QKS Enterprise Transformation Framework. Again, a very busy slide, but I'll take a minute or two, Narayan, if that's okay, to talk through what this is all about. About helping organizations traverse through their enterprise transformation journey. So, if today's discussion resonated with your organization's priorities, we'll be delighted to continue the conversation. Essentially, what we are looking at is a framework that consists of 3 phases, 6 transformation stages, 7 strong foundational capability pillars, a Spark intelligence layer sitting at the center, and some strategic deliverables that guide the journey. So the phase 1 is about illumination, making sure that the organizations improve with their existing setup. The phase 2 is about design, where we acquired and design the OTandIT AI transformation blueprint. And the phase 3 is about really making sure that we deliver the transformation roadmap. Across all these 3 phases, we assess 7 capability pillars that you can see at the bottom of the chart: strategy and leadership, data foundation, technology and infrastructure, process and workflow, people and culture, governance, and value realization. These pillars ensure transformation remains balanced. No one pillar is more important than the other. And what we have learned from working with enterprises is successful AI transformations require all of these 7 pillars to work in tandem. So the reason many AI transformations stall is because organizations focus only on technology, whereas our ETF frameworks make sure that there is a balance across all these 7 pillars. This framework provides a very structured pathway from AI ambition to AI scale, and we have a couple of really good successful business cases that have got deployed across large enterprises. So the output we are looking at here is in terms of a transformation blueprint or a baseline AI roadmap, a governance playbook, and in terms of a final stage, an execution playbook that organizations like yours can use in terms of your AI deployment. So with that, Narayan, a quick preview of the ETF transformation framework. I thought it was important for our audience to look at it. And just I will leave it back to you for any final key takeaways you have.
Yeah, thank you, Devendra. I think that was a good way to conclude the discussions. And run out of just a quick summary, quick takeaways of what we discussed. We said that manufacturing has solved the automation problem. It is not trying to solve the intelligence problem. Intelligence depends on data. Data depends on architecture. And therefore, IT, OT, ET conversation is not just integration. It is a business transformation imperative. So I hope this webinar answered the fundamental question. If AI is the destination, what is the journey that manufacturing organizations must undertake to get there? And we conclude, if you talk to vendors, presentations have started with the AI. If you talk to QKS, our presentation will start with business transformation. Thank you very much. Thank you very much for your active listening, and we look forward to more such conversations. Thank you, Devendra. It was a pleasure co-hosting this webinar with you.
Thank you, Narayan, and thank you, Anish. Thank you.
Okay. Thank you. Thank you very much.
Yeah, thanks, Devendra, and thanks, Narayan. Well, I am pretty dumbstruck listening to both of you throughout the session today, and I'm sure our audience too is. Do reach out to the email IDs that you see in your screen today if you have any further queries to our experts on the session that we had. And as we come towards the end of today's session, I'd like to sincerely thank all of you who joined us and be a part of today's discussion. Well, today's discussion, like clearly Narayan and Devendra highlighted, it is about successful AI transformation in manufacturing begins with strong data foundation, while bringing OT, IT data together is no longer just a technology initiative, but rather it is a cornerstone of enabling industrial AI, digital twin, predictive operations, and scalable enterprise-wide innovation. A special thanks to Narayan and Devendra for sharing your valuable insights and practice on how manufacturers can unify their data landscape and accelerate data transformation with confidence. As a part of AI transformation webinar series that we've been having since the last couple of weeks, do stay tuned for our next session on retail AI transformation from pilot to P&L impact at scale. In this webinar, our advisors will discuss how retailers can move beyond AI pilots and embed AI across merchandising, supply chain, customer experience, and store operations to deliver measurable business and financial impact. Well, if you haven't registered yet, we encourage you to go have a look at it and continue your AI transformation journey with us. Do stay updated with the latest research, our insights, and all our upcoming webinars. And follow us on LinkedIn at qksgroup.com. We look forward to having you all join us in our future sessions as well. Once again, thank you and have a great evening ahead.
Thank you.
Thank you.